A special property of exponential function is that the derivative of e to power x is just e to power x. And therefore, we can use that idea when we find derivatives involving e to power x. For example, in number one, we have f of x is equal to e to power 4x. Now, one thing you can notice here is that that is the power. So in this case, we have a function inside a function. And previously we talked about this, that when you have a function inside another function, you apply chain rule. So basically what we can do here is to find the derivative of this. We can find the derivative of the highlighted expression, which is 4x, multiplied by the derivative of e to power u. And we know that the derivative of e to power something is just e to power something. So basically, the derivative of this function will be the derivative of the highlighted portion, which is just 4 multiplied by e to power u, and u happens to be 4x, and that will be our solution. So we can just uh, rewrite it that way. So that's how you simplify composite functions involving exponentials. In this case here, so f of x is equal to that. So f dash x will be equal to, now 2 is just a constant, so it does not have any effect with e to power x. So the derivative of this term will just be 2 e to power x as it's stated here. Yeah, because k here happens just to be a constant. And then here again we have to apply chain rule. So the derivative of negative 3x will be negative 3 multiplied by e to power negative 3x, because that's like e to power u, which just remains the same. So this solution will be 2 e to power x minus 3 e to power negative 3x. And that will be the required solution. In this case, again, by chain rule, we can start with the inside portion. So f dash x will be equal to the derivative of x over 2, or a half x is just a half, so that will be a half, multiplied by e to power u, which is just e to power x over 2. So the resulting solution will just be a half e to power x over 2. All right, moving on to number 2. Um, Again, just applying the same thing. In number 2, remember here we have to apply chain rule. So this is what is in inside. Yeah. So the derivative of the outside will be, because with the chain rule you start with the outside and then inside. So basically the derivative of the outside will be 3 into bracket e to power x minus x to power 2, because you knock down one unit from the power, or reduce the power by 1. And then the derivative of the inside part will be e to power x is just e to power x, and derivative of x is 1. So our solution will be 3 into e to power x minus 1 multiplied by e to power x minus x uh, to the power of 2. All right, moving on. The next one. Now we can rewrite this expression as 2e to power negative x plus 1 to power a half. And then this is the inside part. So if you apply chain rule, we have f dash x will be equal to a half. We start with the outside, the inside remains the same. So to power negative a half, because if you reduce a half the power by 1, then you end up with 1 minus a half is negative a half. So multiplied by the inside, So if you differentiate the inside, again, you have to apply again chain rule here. So you differentiate that portion. So the derivative of negative x is just -1, so that will be -2, and then e to power, differentiate outside e to power u is just e to power u, so e to power -x. And then, of course, that will just be plus 0 because the derivative of 1 is just 0. So the resulting solution will be, now here, the 2 and the half cancel each other out. So the resulting solution will be, and the negative also, oh, I made a mistake here. That's negative a half. So if you bring that in front, that will be negative a half, and it should be negative 3/2. Because a half minus 1 will be negative 3/2. Perfect. So the 2 cancel, the negative cancel. So what we shall end up with here will be e to power -x into 2e to power -x plus 1 to power -3/2, and that will be the required solution. Moving on to number 3. So find the gradient of gradient function for y equal to this. So basically what we can do is, because we have a product of two functions here, we can apply product rule. So dy over dx will be equal to x squared d over dx of e to power -x plus e to power -x d over dx of x squared. Okay, so basically here we'll have x squared. The derivative of this will be, if you find the derivative of the power first, that will be -1. And then you just have e to power -x plus e to power -x multiplied by 2x. And then we can just put these things together. So -x squared e to power -x plus 2x e to power -x. And that will be the required solution. In part B, because we have a quotient, we'll have to apply quotient rule. So basically, that will be u over v. So dy over dx by quotient rule will be equal to x d over dx of e to power 2x minus e to power 2x d over dx of x, all this over x squared. And then if we simplify this, this will be x multiplied by, again here the derivative of 2x will be 2, and then you just have e to power 2x minus e to power 2x. Derivative of x is 1 over x squared. And we can simplify this further. So this will be 2x e to power 2x minus e to power 2x, all this over x squared. You can factorize out e to power 2x. So you'll have 2x minus 1, all this over x squared. And that will be your required solution. Let me just write this properly. So x squared. Okay, so it all depends on the nature of the question, and then you choose which rule to apply, whether product rule or quotient rule. Moving on to number 4, we have these two functions, and we are required to differentiate this with respect to x. Now again here, note that here um, we need to apply chain rule because you have one function inside another function. So the derivative of 7x squared will be 14x, and then e to power u, and u just happens to be 7x squared, and that will be it. So the whole idea is by chain rule, you start by differentiating the inside or the outside, or outside followed by inside. Then you find the product of the resulting derivatives. Okay, here we can apply the same thing. We just need to rewrite this. So this will be e to power negative into bracket x squared minus 1 plus 1, which will be same as e to power negative x squared minus 1. So dy over dx will be the derivative of um, the inside, and the inside part here happens to be the power. So find the derivative of the highlighted part first, which will be negative 2x, and then multiply by e to power u, so e to power negative x squared minus 1, and that's it. So that's basically how we differentiate that function. Okay, moving on. Number 5, we have this question. So given that y is equals to x squared multiplied by e to power 5x, find the derivative of this function and hence show that this statement is true. So let's start by finding the derivative. This is a product of two functions. So you apply product rule. So dy over dx will be equal to x squared multiplied by e to power 5x plus e to power 5x multiplied by x squared. So this will be equal to x squared multiplied by, now here you have to find the derivative of the inside part. Oops. Um, so basically here I had 5x. So you start with the derivative of the inside part, which is just 5. So you'll have 5e to power 5x plus e to power 5x. Derivative of x squared is 2x. And then you just simplify the resulting solution, which will be 5x squared e to power 5x plus 2x e to power 5x. All right, so what I'm going to do next is just to kind of rewrite this to be able to show that that statement is true. So this is same as 5 multiplied by x squared e to power 5x. If you introduce the brackets, plus, now what I want here is to have something similar to what I have here. So this term here can be written this way. We can have 2 over x multiplied by x squared e to power 5x. And the reason behind this is because I know that y is given by x squared e to power 5x. So basically, I want to rewrite the derivative in terms of the original function. Okay, and you can notice interesting things here, that this is equal to y, and also this is equal to y. So we can rewrite our derivative this way in terms of y. So dy of dx will be equal to 5y plus 2 over x multiplied by y, which is same as 5y plus 2y over x. And basically, this is same as what I have here. So if I just rearrange this equation, I'll end up with dy over dx minus 5y will be equal to 2y over x.